Hello YouTube, De-bodgery here. Welcome to EV Components Review. On the bench is a Kelly controller. This controller was in use and I have just pulled the thing off, so it was a good opportunity to do a teardown of a Kelly controller, which I have yet to do. And so anyway, this is a KVD7245. It's 90 volts max and 100 battery amps max. So it's not a super powerful controller and it's kind of big, but you know, hey, it was doing the job it was supposed to do, so I guess it's good enough. Anyway, the top shell is a piece of plastic. It's too rigid for ABS. I don't know what this is. It doesn't say on the inside. Yeah, there's literally no labeling here or anything. Say it's like polycarbonate or whatever. So I did cut it right here a little bit, and it doesn't crunch like it's glass reinforced, but this is really stiff. So I don't know what this is. We don't know what kind of plastic it is, and it doesn't say anywhere. Anyway, the 5 studs coming out are all come through these silicone grommets. They are not held in place in any way. They just kind of like press down inside in here. So when I put this back together again, I'll put some silicone around here and then stick them in there so that they stay put forever. And that way, if there's any chance of water leakage around them, that won't happen anymore. Battery plus is really here, but you know, that's really the battery plus input into the controller. And then this fuse was across like that. Don't really like the fact that the top of this was completely exposed. You know, the 5 screws, which are hex head screws. In fact, where did I put that one? There it is. Put it back in the bag. So, yeah, the 5 screws are pretty long. I mean, that's what, probably 40 millimeters worth of threads on there, M6 threads, and a 10 millimeter hex head screw. Yeah, you can crank on that a good bit, and Kelly was not worried about you shearing off anything, because that's pretty much not going to happen. These standoffs are what these screws thread into, and they've got 2 M4 screws into them that secure them to the internals of the controller. So this is pretty solid, and this is all a single machine piece of aluminum. So that's probably not going to go anywhere. Anyway, yeah, inside the shell, nothing really special to see here. As you can see, that doesn't go anywhere. That's where you bring battery plus in. Let's set that aside. And inside the shell, you've got these machined areas right here. So this is where battery plus bolts down, and then your 3 phases, and battery minus bolts down here. So everything is bolted down pretty darn securely, and then there's another screw, goes right over here, that's just kind of helping support things a little bit further right where the connector is on the board. But yeah, that's reasonably well secured inside the shell. And you know, it's got its own heatsink on it. Obviously this is just all cast aluminum. But yeah, that's going to do a pretty decent job, or it did, because you know, as you can see, it's pretty weathered on there. That surface was exposed to road grime and grunge and stuff for a good little while, and it did a-okay. Inside here was this little grommet. So this little nut, you tighten it up and then it squeezes around the wires and seals around them, and then this was inside here like that, and then there was a nut that went on the inside, and that was held in place by silicone to seal that in place. But anyway, yeah, that was going to work pretty good. And there's also an O-ring that you can kind of see inside there where it's sat, a rubber O-ring that goes underneath the nut on the inside. So this was pretty waterproof. This controller had seen a lot of use in wet conditions and things like that, and there was no evidence of moisture inside. So yeah, it did its job. Can't really complain about that. Inside here was this thermal and electrically insulating layer. So thermally conductive, electrically insulating pad that goes inside over all those heat spreader areas. And then the bottom side of the board, which is here, that sits down on top of those areas and conducts heat through that. So this just drops in place in here, and there's 2 little posts in the casting here and here that keys the board to the right place, so all the holes line right up. So that just drops right in place and you can't really get it wrong. Up here is battery plus, and that is this piece of aluminum. And the high side MOSFETs, which is this set right here, they just screw right down to this. So as far as a current path is concerned, from the MOSFETs to battery plus, you basically have a standoff which screws down right there by two M4 screws, and then this whole piece of aluminum is both the heat spreader for those and the current path for the battery plus or high side MOSFET. So that's how that part works. Battery minus is this bar right here of aluminum, and you can see these plastic inserts inside here to provide electrical isolation for the screws that go into those and then secure the whole thing to the shell. And this goes in here like that, and no MOSFETs screw to it obviously, and then you have another standoff that screws down right there by two M4 screws. So pretty decent current path. It's all aluminum, of course. And then your phase buses, not only do you have some pretty good sized chunk of copper on here, and it's top and bottom of the board, but then you also have this piece of aluminum in here as well. And so the four low side MOSFETs screw right to this by their tabs. So as far as needing a lot of thermal insulation or electrically isolating thermally conductive materials, you have this, and that's it. You don't have to do anything else in here. So your phase buses, your battery buses are all pretty efficient, and they're all aluminum. So this is not a tortured current path. There's no weak areas here. All that stuff is pretty good. And again, for the phase bus, you have another one of these, and it screws down right there. So this is all pretty decent. As far as getting current from battery minus to the phases and battery plus to the phases, that's all going to work really well. All right, so let me pull out these aluminum blocks so I can pull the board back out and talk about that a little bit. And come out two. There we go. Okay, so you can see all of this area here. This is all battery plus, and you can see the 1,000,001 vias through there. And the bottom of the board is the same way. So you have a really good chunk of copper top and bottom here for battery plus, and that does go to the MOSFETs, but that's not what its primary purpose is. This is really a thermal path, and that's what all of the gazillions of vias in there are for. So this is your heat spreader for the 12 high side MOSFETs. This is the heat spreader for them, and it's also the current path. And then that heat passes down to this part of the aluminum, passes through all of these vias, and down into here. So this is mostly about thermal path rather than current path, because this is your current path right here for the MOSFETs. So you really don't need this for that purpose. And the same thing is true for here too. All those vias in there are for transferring heat away from these aluminum blocks, which sit on top of it, and through all those vias, and then into here. So it's a nice current path too, and it's getting used somewhat for that, but this block of aluminum is the primary phase bus current path. So yeah, this is already pretty good for that, but then you add this on top of it, now you have a pretty darn good current path for your phase buses. Same thing for battery plus. You don't have anything bolting down to battery minus, and as a result you can see it's got far fewer vias on it. They're mostly like right up against the faces of the MOSFETs, and you can definitely see all those vias through here too. But that's plenty enough current carrying path top to bottom of the board for the actual low side MOSFETs. And then of course you've got this added to it as well. So yeah, that's going to be a pretty good current path for battery minus as well. This is going to do the trick for sure. This controller is not going to be lacking or have a weak area in any of its buses. Battery plus, battery minus are both going to be nice and strong. Phase buses are all going to be nice and strong. And the distances between the MOSFETs and all those things is very, very short. So, this is a pretty good bus setup. The only thing about it, or there's two things I don't like about it. One is just kind of complicated because you have lots of parts. You know, like here's the phase bus, right? And then once that's screwed down, then you have to put that on it. So yeah, you have a lot of parts to put together to make that happen. And you know, this is an extruded aluminum piece with several holes machined in it. So you know, that's an expensive part to make. But yeah, I don't know if I would have done it this way. Yeah, I think what I would have done is taken brass or copper and literally soldered it down to the board right here, and then used, you know, these size holes right there with those plastic spacers to then screw this down, and that would have been gracious plenty. But yeah, this is a heat spreader and it's a current path, and this is a heat spreader and a current path too. So kind of overkill, kind of overly complicated, but hey, it works, right? All right, so right here and right here you have 8 330 microfarad capacitors, and right here and here you have 6 220 microfarad capacitors. Why they didn't use 330s everywhere, I don't know. But yeah, that is strange. Also, these ones are 100 volt caps and these are 80 volt caps, which is not really good because this controller is 90 volts max, and so these would be 10 volts over their maximum limit, you know, if you did run it at 90 volts. And this controller was running at 82 volts, so these caps were regularly seeing 2 volts over their maximum limit. So yeah, I would have really liked to have seen these be all 100 volt caps like these ones are, and they're not. Another part of this thing that's kind of strange is the main DC to DC converter. So you see this little board right here, and it was soldered in by its 4-pin connector. So if I pull that out, you can see those 4 pins on there. And I added this connector in it because the board was crooked when I opened up the shell. So it was kind of leaning over like this. And I thought, well, that's weird. Somebody just didn't pay attention to what they were doing when they soldered it in place. So I was just going to unsolder the thing, straighten it up, and then you know, solder it back down again. But instead, I thought, you know what? Why not just put a connector on there, and then later on I'll put some silicone across here so that it can't go anywhere, and then that'll be good. So anyway, it does move right now, but once I get that secured together, that's not going to move. This transistor, so I think that's an NPN. When I do the macro video, I'll talk about all the parts, but yeah, this is part of the DC to DC converter, and on this board you can see the little DC to DC buck chip on there, and you got the inductor and a capacitor. You've got a larger 100 volt cap right here, and this NPN transistor, and that's all the DC to DC converter, the main one. I don't know why they didn't just populate all that stuff all on the main board, or why they didn't just put it all on just a little daughter board or something, but they did this, which again is kind of complicated. And that transistor, it screws down to this little M3 screw hole right here in the corner, so it's not flopping around, it's sitting in there, but it's also in a connector, which is sort of strange. Yeah, I looked at this thing and went, what? That doesn't make any sense. Here's your main I/O connector where all your signals come in, and here is the cable for that. Yeah, you normally get these with some kind of a waterproof connector on them, and well, I cut those all off, and these went into a terminal block. But yeah, anyway, that's all plugs into this connector right here. There is no protection electronics here of any kind. None. I mean, literally none. There's no TVSs or anything here. So yeah, if you have a Kelly controller, I'd have to say be careful, because you can probably blow inputs without too much trouble. Yeah, right there and here are the 3 MOSFET gate drivers. Right here and here you have 2 12-volt linear regulators, and there you've got 2 5-volt linear regulators. So one 5-volt and one 12-volt is for external stuff, and one 12-volt, one 5-volt stuff, or regulator set, is for internal stuff. So that's kind of cool. I like seeing the dual regulator set up. There is no 3.3 volt linear regulator on here, so the CPU runs on 5 volts. I've looked and there's not one here anywhere. I don't know what this connector is for. I'm assuming it's programming. but nothing was plugged in there, so don't know. Yeah, I have no idea what that's for. There is a little 4 op amp package right there, and that's pretty much everything that's on the top side of the board. On the bottom, there's a little 6-pin chip here. I don't think I found what that part is, but yeah, that's pretty much everything there is inside this controller. I'm sort of curious to look at, like, say, one of the 8080i controllers to see if it's laid out similarly simple as this is, because this isn't very complicated. And supposedly the 8080i's are actually field-oriented control, and this one is just trapezoidal. Anyway, yep, I think that's pretty much everything I want to show on this thing. So that one in there, this went here, these went here, this went underneath that transistor, and then at each one of those places a standoff screws down like that. So pretty straightforward design, pretty beefy design. Yeah, this controller has been in use for a good little while, and there was nothing wrong with it. It's just you know, getting pulled and replaced. Anyway, I think that's pretty much everything there is to show off about this controller. Hope to help some folks out. Expect to see a macro video on this coming out pretty soon.